Okay, so quick little lesson today. Oops. And that is going to be on solving basic kinematics problems. In fact, it's going to be more or less a review of what you've done before. All right, so yesterday we learned a lot about displacement. We covered a whole bunch of scenarios where objects were moving around on number lines. And it turns out that in physics that we're going to do, everything is going to be essentially based on motion in sort of one plane, at least when we're doing kinematics, right? We might add vectors that are at right angles to each other, but for the most part, it's stuff moving around on a number line, okay? And we learned yesterday that we might have an initial position, we might have a final position, okay? And this object would move along, and we would say that the difference, the delta d, is found as position 2 subtract position 1. So in this case, we have 1, 2, 3, 4, 5, 6. We have 7 here, and we have 1, 2, 3, 4, 5, 6. Negative 9 here. So your change in displacement here is negative 9 minus 7, or negative 16 meters is your displacement. Your final position is negative 9. Your initial position was 7, and you get negative 16. Just counting to make sure that's right. And it is, okay? So now, this happens over a time period, okay? You can't just like warp from one place to another. That's not the way our world works. You have to spend time moving from one place to another, right? And what we're saying here is our position is changing with respect to time, right? So we're just gonna say that we have a position change with respect to time. Dot, dot, dot. Okay. So we have change with time. Well, when we're calculating or we're metering or we're monitoring change with time, what we're looking at is something called a rate. Okay, so a rate of change is a measure of how something changes with time. Okay, a very common rate would be your rate of pay. Okay, you're probably paid, say $10 an hour or something like that. So that is a monitor of how much you get paid every hour. And if you want to know how much you have at the end, you just simply multiply the number of hours by the rate of pay. So you work 8 hours, well, you made $80 minus taxes. Okay, and the exact same concept applies here, because what we want to know is what is the rate of change in position. Okay, so the general form of a rate is basically this: the change in something over a change in time. Okay, just remember this delta notation, right? What it means whenever you see it is simply this: the final, whatever x is, subtract the initial, whatever x is. So the change in x, and that's over the change in time. Very often, they just give you the amount of time that it happens over, but you might get something where it says like you start a race at 1:15 and end a race at 2:05, right? In that case, you're actually gonna have to figure out what the delta t is. But for the most part, they'll just tell you straight up how much time it happens over, and then you're already given the delta t, so you don't have to worry about it. So what we're gonna look at here is the rate of position change. So that's going to be delta p, delta position. Actually, sorry, let's just be careful here. I'm going to write it in words first. Okay. So we want the rate of change in position over time. Okay, and this has a name. What do we call the rate of change in position over time? What's its name in physics? It's velocity, right? If we're dealing with displacement, we're talking about the velocity. The reason being is that this is to the left, right? And in certain scenarios in physics, you need to know which direction we're talking about, right? So we're using the vector value of displacement, right? It has a direction. In this case, it's negative, right? This is indicating a direction to us. We could have said 16 meters left, but the problem is you can't really do math with the word left, but you can do math with a negative sign, right? So essentially, this negative sign really just means left. It means left. Why? Because you can't do math with the word left. It's impossible. All right, so in this scenario, let's say that this took 8 seconds. All right, it took 8 seconds for this object to move over here. Well, we want to figure out what its rate of change is. So we would say, okay, so we've got delta D over delta T. Okay, and the way you'd often see this is just simply velocity is found as delta D over delta T. But what it really means is final position minus initial position and final time minus initial time. And then in this case, we already figured this out, right? It was negative 16 meters. We go back up and look. Negative 9 minus 7, negative 16 meters. And we're given that this happens over 8 seconds. So what we end up with is 16 divided by 8, which is 2. And the units are meters over seconds. Okay? We, of course, write this a slightly different way. Like that. We're good. So the velocity here is negative, sorry, I almost forgot the negative, negative 2 meters per second. Okay? So let's go look and just make sure that makes sense. So what we're saying is every second this object moves 2 more meters. So let's count. Negative 2. Okay, there's 1 second. 2 seconds. 3 seconds. 4 seconds. 5 seconds. 6 seconds. 7 seconds. And 8 seconds. Perfect. Okay? If this object moves negative 2 meters per second, in 8 seconds, it'll be 16 meters to the left of where it started. Its final position, based on where 0 is negative 9. Okay? That's a velocity. Negative in terms of velocities simply means the direction that it's moving in, right? If we wanted to do the speed of this object now, let's just say we wanted to know its speed. Well, speed is a little different. It's not displacement, but it's distance. Okay? It's distance versus time. Some physicists call this S, just to avoid confusion, where S is displacement. I'm not going to do that. I'm just going to make sure that you know what we're talking about. But just FYI, in some systems of physics, this is just designated as S. That's just a rule of thumb. It doesn't really matter what you call it. The concept is what's important. Okay, so the distance here, well, the distance is just that. It's negative 16, right? Sorry, it's not negative 16. It's just 16, right? It's just 16. There's no such thing as a negative distance over 8. We get that it's 2 meters per second, okay? Distance can never be negative, so speed can never be negative. Velocity can be negative because it's a vector and it's indicating what direction it's traveling in, okay? Where this becomes a little more interesting is if we said, okay, this person walked this way, but then they walked back over to here, okay? Well, now their displacement is less than it was before, but their distance is more. So you can actually end up with different values for this, right? Right. So velocity would be then 16, 15, 14, 13, 12 over 8. Okay, which equals whatever it equals. What is that? 3 halves, 1.5. Okay. And then speed Well, you went 16, 17, 18, 19, 20, right? 28ths. So there's just our values for speed and velocity if this person then turns around and walks back a little ways, right? The distance increased, but the displacement actually decreased. So you get a negative 1.5 meters per second for velocity and a speed of 2.5 meters per second. Okay? Does that make sense? If you're ever in trouble or you're worried or you feel like you can't remember how to do something, draw a number line and count. There's no shame in that. It's a good learning aid. It's a good model for what's happening. Okay? The worst thing you can do to yourself is get all confused about negatives and positives and you know what does it mean and worry about it that way. Draw a picture, it will all make sense. I promise.